Hello, everybody. So that was our third session. Very interesting papers. So remember that if you have any questions, you can put them in the Rocket Chat right here, and the Rocket Chat, and I'll read them out to your audiences, to the paper authors. So I guess while people get warmed up with their questions, I'm gonna ask a particular question on the community pooling paper. So are any of the authors for that paper here? Uh, Federico or any of the co-authors for the community pooling LDA topic modeling and Twitter paper? Okay, I guess uh, they're not uh, they're not here. So moving on to the disentangle sentiment analysis. Are any of the authors for that paper here on the Q&A?
Hello, I am here. I am the first author of this paper.
Oh, great. So one of the questions that I had when I was looking at this, I mean, so yeah, so you do achieve, some better improvements over, the standard data set and all the cool stuff. But do you manage to look at, a set of the improve or different predictions to see, or classifications, so to see if there were, any particularly interesting, things that the disentanglement method did better than others?
Sure, this is the stage that we are starting on doing this ablation study or more further on analysis. At this moment, we only have this primarily results, but we are working right at this moment to have this more fine-grained analysis on the predictions.
Okay, and and full intuition. I mean, we know there's all these transformer models you can try on sentiment analysis. So, why do you think it was, the main difference of this approach
Okay,
versus?
perfect.
Yeah, go ahead.
Perfect. So BERT actually entangles some kind of syntax structure. This is already been studied by, I will not remember the actual work, but I can research later and post here in the chat. So the main idea is that syntax matters. I remember the paper is the UDefine. It's a parser on the universal dependencies, but this work focuses on the parsers, but it has a ablation study on how the BERT learns the syntax structure of a sentence. So BERT, without any changes or using the position encoding vector, summing to the content vector, it already encodes some kind of syntax structure of the data. So this already helps to achieve state-of-the-art results, as we know on the EBCA task. But disentangle those parameters, the position and the content, help it to separate better these concepts and to get better predictions. Did I answer your question
Yeah, no,
correctly? Or?
that's totally good. So we
Yeah.
have a question from William Su. He's asking, can you please specify which Seminole task or tasks that your system was applied to? For example, word sense induction or any other task, and an example of an explanation generated for the Seminole task.
And an example for explanation generated for this. So I think I didn't get the second part, but the first one we used the as sentiment analysis, the aspect-based sentiment analysis task for the semival subtask 4, which is the restaurants and laptops notebook and laptops reviews dataset.
Okay, is there any clarification on the second part of the question, William? Let's see if he posts. Oh, okay. I guess he like your answer. Thank you very much for your responses. Is somebody from the MassNet paper available? I have a question.
Yes. Hello. We're here right now. We are both Alberto and Alexander. We're sharing the same camera and microphone, of course.
Awesome.
Hello.
Well, thanks. So yeah, well, one of my questions before you kept going on, that you did train with people with the mask down, but there weren't enough data samples. Did you try to using anything like GANs or anything to generate a larger artificial data set?
Yeah, I mean, our main data set source was, in fact, I believe, a generated a GAN, no? A GAN that generated faces out from Flickr, the social network, I believe. These images were available publicly, and we made use of them. There are not that many of them because the other images that we use and are that have a mask imposed over the face artificially, well, they are the same images. So we wanted to avoid to repeat the same images for training and validation. That's not something you want to do when training, of course. So we kind of have to separate, well, we are going to use this amount of images without mask. We're going to use this amount with mask, and we're going to use this other amount with the mask put on in the face incorrectly. So we kind of try to complement images with some other sources, like, for example, the humans in the loop data set that we use. A lot of cleanup has to be made because images sometimes they have several faces in the same image, and sometimes they're very, very small, so the quality can be a little bit bad. So we kind of completed the images with some pictures that we took ourselves from friends and family and on the street.
Yeah, and we actually we didn't make again for ourselves because as Alberto was saying, we actually used many artificially made images already, and our results were pretty good. But they started getting better when we tried real images taken either by ourselves or taken from finding on online data sets and things like that. So to answer your question, we pretty much did use GANs. They weren't made from us. They were made from a publicly available data set. And it actually worked pretty good to get the results that we show on the paper.
Nice. Yeah, no, that's good. And now I can advise you, you can look in Twitter. There's a lot of people posting pictures of what they call, at least here in the US, chin diapers, where they have the mask underneath. So if you go for the hashtags, you can actually get a lot of images so you can train your model. Well, thanks. Any other questions that we have around here? Okay, so I guess that's oh no, we still have nope, yeah, no, we have to go on break now. Well, thank you very much for the authors of the papers for being here and answering our questions, and we'll come back with Professor Ana Basan after our short break. Thank you very
Thank
much
you.
for
Okay.
being around.
Thank you for your time. Thank you.